DCC has got a lot to offer modern railway enthusiasts, but it can be an expensive enterprise. You have to have decoders in each loco, which can be expensive, but we're looking today at the controllers for them. A typical Hornby controller, £300, £600, and even the cheaper ones, we're still looking at £153. So today we want to look at an entry point, people who want to decide whether DCC is for them, tip their toe in the water and decide whether it's worth it. Just buying one or two decoders and a basic DCC controller. So what are the basic options to get started? Well, a piece of hardware that will connect to the track to power the locos under the control of software in your computer. This is the well-known and well-liked Sprague interface. Works straight out the box. You simply connect the track power to two of the terminals, the track itself to the two other terminals, and connect the unit to your computer via the USB port. It's supplied in two versions depending on how much current you expect your layout to consume. It is often used in conjunction with control software from JMRI. Open source software, so it's free and very well endowed in terms of features. The one we want to look at is using it as a simple throttle. And here we have it, a clear, easy to understand interface. At the bottom we can select any local decoder address. The left hand panel lets us set the speed on a slider, and we can click to forward or reverse or emergency stop. And then if our decoder has various functions, then we can call them up from the functions panel. The one that I want to look at, however, today is cheaper still, with the hardware coming in at under £10 UK, and once again the software being free. The hardware is in two parts. First of all, an Arduino Uno or Mega, which controls all the operations and interfaces to the computer. Don't worry, there is no programming knowledge involved whatsoever. And then a motor shield, which supplies the additional power to the track, as the Arduinos are not able to supply sufficient current. And then the two of these units plug together, as you'll see later. Here is the current price of an Arduino Uno, and here is the current price of the motor shield. Together, slightly under £9 in total. Your only financial outlay to create the throttle. Right, let's look at the shield in a bit more detail. As you can see on the left hand side, there's a 6 screw terminal block. The bottom two is for your power supply that's going to be feeding both the module itself but also the track eventually. Above it, the two terminals go to the main track of your layout, and the top two are if you need to have a programming track so that you can program your CVs using the software. The software that I'm going to use with it has got an option to join the two sections of track. In other words, a siding can be used isolated to set up CVs of your decoders, and when that's done, then use it as an ordinary siding as part of your working layout. So if you're happy to run your layout at 12 volts, there's nothing you need to do to the shield. However, since many DCC systems use 14 or 15 volts, we have a problem potentially. The voltage that you see coming in as track power on the terminal block also routes over to where you see the power circled on the pins. And because we intend to plug the two units together, we're going to extend that voltage through to the Uno, which is fine if you're running at 12 volts. But if you increase it to 14 or 15, then you're going to blow the Arduino. So how do we get round this? Well, if we turn the shield module over onto its rear, we'll see there are three sets of pads with a fine connection between them. And there's one called V-in connect. If we break the link between those pads, then we can feed the Uno separately from the track power. Something like this. This is a quick mock-up. You would probably mount the regulator and its various capacitors on a separate little board. But you can see the 15 volts is feeding the track, but the 15 volts then feeds through the 9 volt regulator to provide 9 volts to the Uno, and we take that to the Uno's V-in connection. All we need to do now is connect a USB cable from the laptop or the desktop to the USB socket on the Uno and carefully plug the two units together. Like this. You can see the power supply coming in, you can see the yellow wires going out to the track and the USB cable to connect to your computer. And that's all you have to do if you're having a high voltage, like 14, 15 volts supply. If you're happy to run it at 12, then there's no modifications required whatsoever. And now we can think of moving on to look at the software. We require two pieces of software. One, the program that goes onto the Uno to handle all the operations, and then the software that we put onto your computer to allow you to choose locals, control the speed, etc. Very similar to the JMRI throttle we looked at earlier. In this case, however, we're going to be using two pieces of software available from a non-profit site called DCC EX. The first piece of software is to go on to the Uno. I did mention that there is no need for any programming knowledge, so they have kindly created an installer where you download and run the exe file and it does it all for you. Let's check this out. So I have downloaded the installer program, and you'd normally click or double click to run it. I found that it sometimes doesn't work unless you run as administrator. It opens this screen, and first of all I have to click down here and then select my device and put it onto a Uno. Which product? the command station. Then configure it if required. I've none of these options. I'm running it simply. I'm not using Ethernet or Wi-Fi or whatever. And I'm using the standard motor shield. Compile and load. Click load. And we're finished. We can now close the application. Okay, now that we've put the software on the Uno, there's the software we put onto the computer. And it's provided by the same people, DCC EX. And you can see it looks very similar to the JMRI version. You have two options. You can run this software straight from the cloud. It saves you loading anything onto your computer, but of course that means you're tied to having an internet connection. Or you can download the software onto your PC and you're then running independent of any internet connection. And that's the one I want to look at now. When you click download, you'll download a zip file which you can then unzip into a folder of your choice, and then it'll look like this. And then we run it this way. Right, we're now ready to test it on a small section 1 foot of N-gauge track to see it perform. So here is the WebThrottle folder. Inside it we have the index file which we want to run, so we right click and open it either with Edge or with Chrome. We have a grayed out panel. We want to connect using the USB port of the Uno, so we allow that option to stand and click connect. We know that the Uno uses COM9, so we select it and connect. And now the panel becomes live. At this point, we can switch off and on the track power. Or we can select a loco either by its address or from a pre-prepared list on a roster. We'll just select address 3, put the power on, and now we can set the speed forward or reverse. Emergency stop. Can restart. If we have functions in our decoder, we can click on them to activate them. And we can then change to a different local address and do the exact same thing in forward or reverse. Now let's see how well it performs on the test track. And finally, what kind of performance can we expect from it? Well, we're looking at a narrow gauge 009 loco, so working in 00 scale. It takes 80 seconds to go 1 foot on that sample piece of track. In other words, it's running at a scale speed of less than 1 mile per hour and smoothly. So I think we can take it that the shield is working perfectly happily. So there we have it, a basic DCC controller for under £10.